Dear students, today we are going to look the limiters for iron. The limiters is quantitative or semi-quantitative test in order to find the amount of impurity present in the given sample. Here we are looking the presence of iron impurity in the given sample. So here also we are comparing the color intensity of two Nessler cylinder, that is one was test and the other was standard. Next, we can move forward for the limiters for iron. Principle behind the limiters for iron. Here, the iron reacted with thioglycolic acid. So, this reaction is taken place in an alkaline medium, that is ammoniacal solution. So, the reaction is taken place only in alkaline medium. The reaction is taken place in acid and the neutral medium, but the end product is colorless in the case of acid and the neutral medium. So, we can't able to detect the color change. So, only in alkaline medium we can able to detect the color change. So we are using ammoniacal solution for making the solution alkaline. So the iron reacted with thioglycolic acid in the presence of citric acid. Here the citric acid is added in order to prevent the interference of other metal cation with the reactions or with this complex. So, and to form a iron thioglycolate complex. The color of this iron thioglycolate complex is pale pink to deep reddish purple in color. So we are comparing the intensity of this color of test with that of the standard. So please look this reaction. Iron can exist in two forms, ferric form as well as in the ferrous form. So Fe3 plus this ferric form is converted into ferrous form in first reaction, that is converted into ferric form. This ferric form of iron reacted with thioglycolic acid, that is Fe2 plus is reacted with two molecule of thioglycolic acid and to form the ferric thioglycolate complex, that is Fe is at the center, that is iron molecule is a center, and this H is one molecule of thioglycolic acid. Here we can see the one molecule of thioglycolic acid. This H is removed and the remaining OOC CH2SH. One molecule of thioglycolic acid is on the one side and in another side this H is removed. So OOC CH2SH, another molecule of thioglycolic acid, and to form a ferrous thioglycolate complex. The color of this ferrous thioglycolate complex was pale pink to deep reddish purple color. This color is formed on both the standard and the test, and we are comparing the color change in both the test and the standard. By comparing the intensity of this color, we are explaining our test is pass or fail. Next, the various chemicals that we are used for the limiters of iron. That was first iron-free citric acid. The reason behind the citric acid was used, which may be prevent the interference of any other metal cation with this complex and also with the various reagents. Okay, then 20% of citric acid was added for the reaction, and also 2 gram of citric acid in 100 ml of water to form 20% weight by volume solution of citric acid. So citric acid is added in order to prevent the interference of other metal cations. Next, we are adding 10% weight by volume of ammonia in water. Ammonia solution is added in order for making the solution alkaline. So, the complex formation, that is complex, should be colored in ammonium solution or in alkaline solution. In acidic and neutral solution, the iron thioglycolate complex should be colorless. So we can't able to identify the color of this complex in case of acid or neutral solution. In alkaline solution only, we can able to detect the color of iron thioglycolate complex, so that we are making the solution alkaline by adding ammonia. Next, we need the standard iron solution. The standard iron solution was prepared by weighing accurately about 0.1728 gram of ferric ammonium sulfate and dissolve in 10 ml of 0.1 normal sulfuric acid and make up the volume to 1000 ml with water. So we are making the standard solution using this procedure. That is 1 ml is equal to 0.02 mg of iron. So we are taking this standard solution in the standard apparatus. Next, the reason behind the adding the various reagent. First is thioglycolic acid. Here the thioglycolic acid is a strong reducing agent. So ferric ion present in the reagent or in the sample solution was converted into ferrous ion, which react with thioglycolic acid and to form the ferrous thioglycolate complex. Next, we are adding ammonia. As I already mentioned, ammonia make the solution alkaline. So, in the case of acidic or neutral solution, the ferrous thioglycolate complex should be colorless. So, we can't able to identify or detect the color change. Next, we are adding 20% weight by volume of citric acid in order to prevent the interference of other metal cation. We are adding iron-free citric acid, which is used to form the complex with the metal cation other than the iron, if any. So, which can be prevent the interference of metal cation with that of the complex. Okay, now we can look the procedure behind the limiters for iron. So we need two Nessler cylinder. One is for test and other is for the standard. So in test Nessler cylinder, we can dissolve a specific quantity of sample solution. And in standard, we need 2 ml of standard iron solution. Okay, then dilute it to 40 ml with distilled water, both the test and the standard. Next, we are adding 2 ml of 20% iron-free citric acid. We are adding citric acid in order to prevent the interference of any other metal cation with the complex. Okay, then we are adding 0.1 ml of thioglycolic acid in both the standard and the test. So thioglycolic acid is a reducing agent and at the same time which may be interact with this iron to form the ferrous thioglycolate complex which form the color. Okay, next at last we are making the solution, both the test and the standard solution, alkaline by adding iron-free ammonium solution. We are adding iron-free ammonium solution in both the test and the standard for making the solution alkaline, and add 50 ml of water. We are make up the Nessler cylinder by adding dilute with 50 ml of water. Then after that immediately stir with the glass rod. We need Separate glass rod for standard and the test and wait for 5 minutes. We can see a purple color is formed in both the test and the standard. So we are comparing the intensity of this purple color in the test and the standard for the prediction, for the evaluation whether our sample is pass or fail the limiters for iron. This was the apparatus, that is Nessler cylinders. We need two Nessler cylinder, one is for the test and one is for the standard, and which has two marking. There is one 25 ml marking and also one 50 ml marking. So you can see this Nessler cylinder in your respective labs. Next, we can look the precautions. As I already mentioned, we need two glass rods, separate glass rod for test and the standard, because otherwise it will affect your observation if we use the same glass rod for both the test and the standard. So we need the different glass rod. Next, the observation and inference for the sample 1, that is, if the color produced in the test solution is less than that of the standard, as we know, the inference should be the given substance pass the limiters for iron as per the Indian pharmacopoeia, while compared with that of the standard substance. Next, the second observation was if the intensity of the purple color produced in the test solution is more than that of the standard solution, the inference was like that the given substance failed the limiters for iron as per the Indian pharmacopoeia when we compare it with the standard substance.